This right here is a tap sensor. It's used to check for vibrations or taps that could be made by a knock or something as simple as a very light shake. Just before we start, I want to say that if this video helped you out, there's so many more coming onto the channel, and there's ones that we've made before. So all you have to do is hit that subscription button, like the video, and if it does help you out, please do watch until the end. If there's any other sensors you want to see me review or break down or teach, just let me know in the comments. This tap sensor isn't one that we typically see around the house like the things we've reviewed previously on this channel. But a cool project you could do with this is set it up on a door or a cabinet with all your hidden snacks that you want to hide from everyone, and make some sort of secret knock pattern that when it activates, it will unlock the door using a sensor. Or you can put it on something that should never move. If it ever moves, this sensor will feel that vibration and let you know right away, and you could set it up with an alarm or something cool like that. There are a lot of different versions of this specific sensor right here, but they're all very similar because of the way they work, which we're going to go over in a sec. So just make sure that when you're following along, that you set up your pins with your little cables the way that it's meant for your board and not for mine if you have a different model. But the code and everything like that should still work for your model, even if it's not the same as mine. It's going to be a little bit hard for me to show you exactly how this works, but inside this plastic piece right here, there's a spring. One side is holding the spring, and the other side, the spring is loose in the air to fling around. Now, where it flings around, there's a metal contact patch either inside the spring or at the bottom of it or at the top. Somewhere that when the spring moves, it will touch one of those pieces of metal, closing the electrical circuit and letting electricity flow through the spring from one metal prong, which I can show you actually on the back right here. So if you look right here under this piece of plastic, you'll see two pieces of metal. Let me focus it up here. So right here, there's one piece of metal and there's one right there, and then the spring connects them both when it vibrates and touches one of the pads. So using that spring, we're able to detect vibrations because the spring will always return back to its straight and natural position as long as nothing's broken in there. Meaning that this switch will turn on and off with vibrations. Now this will not sense sensitivity, but you can sense other things like how long the spring has been touching the pad, or maybe a pattern, which is what I was saying earlier, that if you knock and you wait 2 seconds and you start knocking again, you can detect those patterns of knocks and vibrations and then turn it into something to unlock a door, to whatever you'd like. All right, so to connect it up, we're going to need a couple of different things. We're going to need the sensor itself. We're going to need an Arduino. It doesn't matter what type of Arduino you use. A replica is what I'm using. You can use other types of boards. The code should work for all of them. You're just going to have to set it up a little bit differently. But these are fine. Arduino Micro, Mega, whatever the other variations are called, those work too. Then you got some cables that you need. I got 3 with different colors. And then the sensor itself, as I said. I also have a cable here, which I'm going to use to plug in everything to my computer so I can upload the code to the board. So before we do that, let's grab our Arduino, let's grab our sensor, and let's connect it all up. On the sensor itself, as you saw earlier, there was 3 pins. I'm going to move it up here one more time. There's 3 pins. We have an S pin, a plus, and a minus. Plus and minus is our power on the plus, and then minus is our ground. And S is our signal. That's the one that's going to tell the board all the information we need. Yours, if it's not the same exact one as mine, might have a different order. So just make sure that you connect yours properly for your board. Otherwise, everything's the same. So for us, we're going to be plugging in the black in the minus, the red in the middle on the plus, and then the yellow on the S. It's also important to look at what kind of power your board can take, or your sensor can take. This one can take both 5 volts and 3 volts. I'm going to use 3 volts just to be safe. So there we go. We plugged in our black. We're going to plug it into our Arduino. Black should be ground as always. Red, we're going to plug into 3 volts. And yellow, I'm going to plug into 7. 7 on the digital line, on digital PWM. That's what they're called. So once that's plugged in, we can plug it into our Arduino. Just make sure everything's good. You don't want to burn your little sensor. I'm going to plug that into the computer right there. And now we can see the lights turn on our board and we have some power. So then we're going to open up our Arduino editor here. And the first thing we want to do is declare our variables. So we're going to go and declare an integer and call it pin and make that equal to 7 because that's where we plugged in our yellow cable on the Arduino board. That's our signal cable. That's where our information will be coming from. Then we have to declare another one, and that's going to be tap status. You can call this whatever you want. I just called it tap status so I remember what it is. Then we have to go into our setup and we have to do two things. First, we have to tell it that 7, which is the number we picked earlier, is going to be an input pin. So we're going to put the pin, and then we're going to put the word input in capitals. That lets the program know that 7 will be our input pin, so everything should be pushed to there. Then we need to do something called serial. We need to tell it to begin, and then we're just going to give it a frequency to run on, 9600. So when we print out messages, we can read them. Like if we want to, every time we tap, we can have the sensor tell us that it's being tapped with actual English words instead of random numbers. Then we can go straight into our loop, and this is where we have like the functional stuff. So we're gonna first take our tap status and we're gonna set it equal to digital read, which is us reading the pin, digital read. And inside of that, we're gonna put our pin number 7, because as we declared up here, pin mode, pin input, we're gonna read from an input pin on number 7. It might look a little confusing, but it makes it a lot more organized instead of putting 7 here and 7 here. Because then when you want to change it, you can just go to the top and change it once instead of all these different places. So we did that. Now we can go and let's do what we said earlier, actually. Let's go and make a little if statement, and then inside of here, we're going to say tap status, and then under that, we can do serial.println. And inside of there, we can say a message like, now one thing that's important to note is with this specific sensor, on is off and off is on. It's not that weird. You can try it like this, but then it's always gonna say tap until you tap, and then it's never gonna say tap. So what we're gonna do is we're just gonna put this little exclamation point which just reverses the input. So we can go and save that if you'd like. I'm not gonna save it. Let's make sure in the tools at the top here that we have our type of board selected. So just make sure you selected whatever board you're using, and then you have to go and select the ports that it's connected to. If you don't know, you can try them all. Usually it takes 2 minutes. So we're gonna do that. Then we're gonna go and open up our serial monitor. We're gonna upload this. I'm not gonna save that. One more time, we're gonna open up our serial monitor. And now it shouldn't say anything. Now, when we tap our sensor, it should say, I've been tapped. So let's try it out. We didn't see anything. Let's try one more time on the side here. There we go. I need to be a little bit harder on this because it's not connected to anything, but maybe I could just smack it lightly along the table here. See that? You'll see that it does catch it like 4 or 5 times per tap. So if I do it again here, see how it catches it like 5-6 times? That's normal because the spring does touch the contact patch for a couple of loops before it lets go again. That's your loop right here. So you could do a couple different things, like you can go and make your loop have a little delay in it. So we can delay here with like a really tiny number like this, let's say. 50 milliseconds, and let's upload that. But what I'd rather do is get an average number. Does it usually show 5 or 6 taps? And then in your code, you can write it for that 5 to 6 taps to be equal to 1. Because it's normal that it's going to stick to it for a little bit of time. So let's actually clean this here. Let's tap it one more time. Oh, and now I broke it. Now it's not working at all. See that? So let's get rid of our delay. And instead, whenever you're sensing for taps, you can figure out a smart way to consider 6 or 5 taps at once to be equal to 1. If you wanted to do a pattern, if you just wanted to sense a tap in general, it really doesn't matter how many there are as long as there's more than 1, or sorry, more than 0. So there's our taps one more time. Let's go open up our serial monitor. Let's clear that. There we go. Now we're working again. And you see now it's 2, now it's 5, now it's 3, now it's 4. So it seems like the harder I hit it, usually the more it is. Because that spring kind of stays for the tiniest amount of time on that little platform. But other than that, that's pretty much it. That's how you use a tap sensor. If you enjoyed the video, if it helped you out, please do give it a like and check out the next video that's going to be coming out either tomorrow or whatever the next day is on another sensor. If you have any sensors you want me to look at, please do let me know. I'm going to run out of sensors at one point and I need the help from you guys to find more.